Hey, let's go. Welcome to the live broadcast of Wireless Tuesday. Thank you so much for joining. Today, we are using WebEx Event Center to bring you this live broadcast, and we want to make sure that you have a great experience. If you are having any trouble seeing or hearing, please use the chat feature within WebEx Event Center. It's a little speech bubble button, and make sure you send that chat to all panelists. We'll help you get things sorted out. Now, if you have any questions for our guest today, please use the Q&A feature within WebEx. It has a little button that looks like a question mark, and make sure that you send that to all panelists. We'll make sure that your question gets answered or addressed, and we will make sure to take all of the questions following the broadcast and put them on ciscofullbars.com so you can have access to those later on. Now, after the event, you're going to get a poll, and to tell you the truth, I won all fives. But if I didn't earn a 5, please give me what I earned, but also tell me what I could have done to earn your 5. And also, a lot of our topics are derived from suggestions from people like you. So please let me know what kind of topics you would like to hear next month. Now stand by for the beginning of the broadcast.
Welcome, welcome, welcome. I hope you're as excited as I am. It's Wireless Tuesday. Wireless Tuesday is a monthly podcast that revolves around Cisco wireless LAN and related technologies. It's a way for me and my colleagues on the Cisco Global Wireless team to give back to the community that's given us so much. My name is Jason Grant, and I'm your host. Let's get it going. It's Wireless Tuesday.
And we're back for a special edition of Wireless Tuesday. Today, I am pleased to bring back Stefan Heinsius, who presented 7 ways to fail as a wireless engineer last week. And, he went back and thought, hey, there's some more ways that we can really make a fool of ourselves. So we're going to talk about 7 new ways to fail as a wireless engineer. Stefan, thanks for coming back.
Thanks for having me.
Absolutely. So what do you got for us?
So 7 new ways to fail. Like I said last week, I don't think that I'm sharing anything new to you, but what I want to give is some tools for you to explain to non-technical people, to non-Wi-Fi people, why things are wrong. And that's what I wanted to do with the 7 new ways to fail. Shall we get started?
Yes, please. Let's do it.
All right. So we have 7 new ways to fail. Quick introduction, a quick recap from what we learned last week, and then we're going to look into fail 1, 2, 3, 4, 5, 6, and 7, and a little conclusion. So a quick introduction for the people that missed me last week. This is my Twitter handle, @StevenHeinsius. If you want to follow me, that's where to find me. I worked as an end user for 3 years. I worked for a water facility company in the Netherlands. I worked as a field engineer with a partner, 6 years with a distributor. I'm with 7 years with Cisco. It's going to be 8 this year. I'm 13 years CCSI, a Cisco instructor. And in my spare time, I'm a dad, a husband, a runner, a cook, a mountain biker, a scuba diver, a snowboarder, and I'm a Wi-Fi enthusiast. So let's get started. Why these sessions? Well, this is how I feel when there is no Wi-Fi. If you look at Maslow and the basic needs, you could say that Wi-Fi is by now a basic need, and a big issue is when there is no Wi-Fi. And for some reason, Wi-Fi always seems to fail when you need it the most. A funny note on that is we're going to do a demo today. I already did a quick spectrum analysis on my Wi-Fi, and I found a source of interference that I simply cannot take off. So especially when I needed the Wi-Fi the most, I have a big source of interference, but you'll see that in the demo. And looking at Wi-Fi, not everything is better without wires. I always say, and with me a lot of people specialized in Wi-Fi, they come to us and say, we want to do an all wireless office. And we have a rule, and the rule is if it doesn't move, plug in a wire. Okay? So even if you're going to go an all wireless office, that's great. You can do that, and we fully support that. But if it doesn't move, plug in a wire. So if you're going to have a video screen, even though it's capable of plugging it or doing it wireless, plug in a cable. If you have a printer, why would you want to have your printer wireless? I still don't understand that. You don't walk around the office with your printer, so just plug in a wire. Not everything is better without wires. At the end of the session, I want you to become a wireless superhero, and we're going to give you the tools for that. At the same time, I want to warn you, don't tell your friends and family that you have all the knowledge on Wi-Fi, because before you know it, you will spend Christmas Eve, instead of having dinner with your friends, you're fixing their Wi-Fi while they have dinner. And I can tell from experience. However, if you fix something, this is how I feel. You feel like, yeah, I fixed your Wi-Fi. So, a quick recap of what you missed last week. You can still go back, and probably, Jason, you're able to plug in the hot link here to go back to last week's session. But in case you missed it, I created a summary. This is a 2-page summary that's called the famous 14. Those are the 14 fails. We can do a quick recap on Wi-Fi, but in this audience I really don't have to explain that it's a shared medium, it's half duplex, every message needs to be acknowledged. In this audience everyone knows that. However, the famous 14, you can reach out to me on Twitter or email if you're not on Twitter, and you can get the 2-page document. Fail number 1 that you've seen last week, the incorrect usage of channels. This is where a friendly fellow parked his car in channel 4, and basically he took out 2 parking spaces. If you want to see this in Wi-Fi, this is how it looks like. So you see channel 4 being used and basically taking out channel 1 and 6. And this is, for the record, this is a picture I took in a Cisco office, in the Cisco UK office to be precise. But this is how it looks like when you use the wrong channel. Fail number 2, putting your access points on maximum power. And basically, too much power isn't good for anyone. I mean, look at some precedents that we have. Too much power isn't good. Jason Hintersteiner, he is he works for Ingenious nowadays, and he said it great. He said, setting transmission power is like drinking scotch. The right amount is great, but more does not mean better, and too much will make you sick. So I can't agree more than what Jason said there. Fail number 3, 2.4 gigahertz, still the most important. Well, some people would say 2.4 gigahertz is dead. I would not go that far. I would say 2.4 gigahertz is still around, and you still need it. And especially with 802.11ax around the corner, 2.4 gigahertz will be utilized again. However, designing your infrastructure for 2.4 gigahertz is not the way to do it. So design with 5 gigahertz in mind. Fail number 4, a very favorite one, putting your access points the wrong way, putting them behind metal cages and stuff like that. Yes, it really matters how you position your access points. Another common mistake is to put a ceiling mount AP on the wall. Then you get the wrong polarization. So that's a very common one. Underestimating security. Well, I actually had a conversation with one of our customers that explained to me that to prevent the WPA2 crack, they went back to web encryption. Well, then you're really underestimating security. So fail number 5 is underestimating security. Fail number 6, the hype versus reality. It's all about the big shiny numbers that we want to put in the box, but the reality is a little bit different. So if you have the expectation to be with the love of your life, being the king of the world, but the reality is a bite of the nose, then you're really disappointed. So I want you to understand how the basics and the calculations work for Wi-Fi, to better understand that the number they put on the box isn't necessarily the reality. And fail number 7 is about no proper site survey. I had conversations with wireless experts that told me they put one device in tethering mode and then walk around with a second device to see what is the coverage area. The logic they put behind it is they say if we can make it work in this way and we put in a professional access point, then for sure we're going to have coverage. Well, that is not a proper site survey. So if you want to go back in this, we have the sessions recorded for Cisco Live, and of course we recorded it last week as well for Wireless Tuesday, so you can go back in the Wireless Tuesday recording as well. So, show me the new stuff. Fail number one. Fail number one is like rip and replace a like for like. So, you decided to upgrade your infrastructure. Well, that is obviously not a fail. In this case, I'm going to show you a wireless infrastructure of a hotel where I stay quite often. This is a hotel somewhere in the UK. It's a big hotel chain, and they used Cisco 2600 series access points. And everywhere where I come, I always do a scan of the Wi-Fi, so I do that here as well. And in this case, the 2600 series of access points is an 802.11n series access point. Very good access point. A lot of them have been deployed worldwide, and a lot of happy customers with them. However, in this hotel, they were not happy with it because the performance was not good. The interesting thing on that is, as you can see, the maximum data rate is 54 megabits per second. If you recall, the 802.11n is the standard for the 2600. So, how is this possible? If you look at the 2600 series of access point and you're gonna turn off wireless multimedia, this is the result. Because in the Wi-Fi Alliance, they agreed that in order to be supporting 802.11n, two things are mandatory: wireless multimedia and AES encryption. If you turn either one of them off, automatically you fall back on 802.11g as a standard. In this case, you will see 54 megabits per second. So what did they do? They rip and replace the entire infrastructure. Now, don't get me wrong, I'm happy with that because I'm selling access points, but their installer upgraded the entire infrastructure by replacing them with the latest and greatest Cisco access points. And this is how the infrastructure looked like now. And the interesting thing is, they're still not happy. Look what they did. They put all access points on the same channel. So even though you're upgrading all your access points to the latest and greatest, you're still not happy because of all the access points on the same channel. Now, if you're going to replace your infrastructure, it's really important to do a new site survey. So if you're upgrading your infrastructure, you can't just take out one AP and put in a new one. So like-for-like upgrades is never a wise thing to just take out one AP and put in another one, because the radios that are in the access points are completely different. You can't take out an 1142 and put in the 2802. The reason for that is that the radio and the radio pattern as provided by the access point is completely different. And the radio for the 2802 is a lot more powerful than the ones for the 1142. So if you just take out one and put in another, you get a lot of what they call co-channel interference. And another thing is that if you're going to do a site survey with a 2802 with integrated antenna, and then you're going to put in the 2802 with external antenna, you get a completely different radio pattern. So you cannot do that. You need to do a site survey with the access point that you want to install. So I'm introducing a new thing in the 7 new ways to fail, and it's my simple rules. So here's my first simple rule. The simple rule is survey for the access point you will install. So that is simple rule number 1. Fail number 2, BYOA. BYOA, you might be thinking, I already know BYOD. And a lot more companies nowadays support BYOD. However, it means something different than you think. Apparently it means bring your own dog, and yes, there are more and more companies that support that. Alright, so now we're not going to talk about BYOD. I think you've already seen way too much sessions about bring your own device. However, a lot of people are interested in bring your own device, and some people take it quite far. So being in the train and bringing your home desktop machine into the train, that's a great example of bring your own device. And if you're in the McDonald's and you don't have a laptop, why not bring your full machine, right? But no, BYOA is all about bringing your own AP. Let me take you back to the year 2009. And in 2009, I was working for a big distributor, and we deployed enterprise Wi-Fi throughout the entire premise, but not everywhere there was proper coverage. So one employee brought his own WRT54G, and I think that people on the call, at least half of them have had this machine, right? I mean, you could even install your own firmware on it, and some people still even use this one. But in this case, in this big distributor, someone brought in this access point and put it in the warehouse, and he had his own wireless network deployed there. However, he put it all on the defaults, so basically it was a security issue. And we see the same thing nowadays in 2018, where people put in their phone in tethering mode inside the enterprise and use corporate devices to connect through the internet, through this device to the internet. And that's an issue because it's not secured with the network credentials. You're not having 802.1x. It might be interfering, and basically you're having corporate devices connecting to the internet through an unmanaged infrastructure. So it's a security breach. So how do you protect an infrastructure like that? Well, you can do it this way, but let's be honest, that's not really properly secured, right? So my recommendation today would be to look at SDXs. In an SDXs, you create a fabric, and in the fabric you have segmentation based on TrustSec, on a scalable group tag, and devices that are corporate, non-corporate get a label and get tagged and get allowed on or off the network. And an access point, if a rogue access point would be put in this infrastructure, they would simply not be part of the fabric and would simply not get access to the internet. So with that, you can do policies, you can have segmentation all the way through the infrastructure, knowing what is corporate, what is non-corporate, guests get their own policies, and you can simply have the security end-to-end in your entire infrastructure, and at the same time maintain the operation simplification. So my second simple rule is for this infrastructure, and it says a rogue AP should never have IP. Okay? So if you have a rogue access point plugged into your infrastructure, it should not have the possibility to even get an IP address. Moving into field number 3, supporting legacy devices. And some people will convince you that they need to support their 802.11b clients. And mind the capital B in this case. That's a funny note. And they say we still need to support B clients. And definitely we do not need to support B clients. If you still have B clients in your infrastructure, it's really time to migrate. At the same time, we have conversations with our customers and they tell us we need to support those barcode scanners. And we still see a lot of barcode scanners that are only on 802.11a, B, and G infrastructure. Hopefully they're on N already, but a lot of them are still on A, B, and G. And they tell us we need to maintain those devices. I had a customer that brought his card bus devices and said, I need to support this because those card bus go into a moving machine, a PLC environment where the moving device uses card bus. So we need to support that. And Jason, do you recall what is this device?
That looks like an original iPhone.
You are absolutely right. This is the original iPhone. Yes. And I know you will not see this in a corporate environment, but I had to bring this picture in. I mean, we have to remind that the original iPhone is a Cisco device. So, in order to supporting clients, you have to understand what type of clients do you need on your infrastructure. Okay, so look into the details, look into the specs of those clients. Then look, what are the capabilities of those clients? Do they support 802.11g, N? Are they 2.4? Are they 5? What encryption mechanisms do they need? Do they need TKIP? In case if you need to support TKIP, like those barcode scanners, you can support TKIP. And don't get me wrong, TKIP is not secure. However, if you're going to put your SSIDs for supporting TKIP, it will reduce the data rate. So look at what capabilities those clients need. What applications are you using and what are the requirements for those applications? So do you need a low latency? Do you need a short round trip time? What is required for those applications? And what is the required capacity? With that, if you know these things about your clients, you can properly design your infrastructure. So 5 gigahertz only, if possible. Okay? My recommendation today would be in an enterprise environment to create a 5 gigahertz only SSID. If you still need to give support for 2.4, or you need to support for TKIP, you would enable a separate SSID. And there you would enable 2.4 or TKIP or both. Closely monitor channel utilization. So you can go into the wireless LAN controller and see the channel utilization. Monitoring for channel changing. So if you see a lot of channel changes, there must be interference. Configure 802.11k on the wireless LAN for iOS devices. 802.11v for BSS transition management to help to balance the load and manage the data rate. So you've seen this before, you will see it later as well. Create a smaller cell with a higher data rate. So in that case you will have a better performance for all devices. If you want to go to the details, we have the Cisco and Apple best practices overview, and you can simply click on the link there and it will bring you to the white paper. So my simple rule, legacy devices should have a separate SSID. We see the same thing within Cisco. Our corporate environment is called Blizzard. Blizzard is 5 gigahertz only, and we have a secondary SSID called Blizzard Legacy, and there we have 2.4 enabled. So fail number 4, design for coverage. Do yourself a favor and enable, in this case I've got 12 megabits per second as the lowest mandatory data rate. The lowest mandatory data rate is used for the multicast and for the broadcast, and that's also used for the beaconing. So the lowest mandatory data rate is used for that. The highest mandatory data rate is used for the multicast. So in this case we have a coverage cell for an access point, and I would recommend to not put it on 1 megabits per second as the lowest mandatory data rate, which is by default enabled. So my recommendation would be to actually reduce it, if possible even to 18 megabytes per second and maybe even 24, and then simply put in more access points to create the same coverage area. So in this case you see an access point transmitting and saying I support 54, 84, 36 and 24 megabits per second. And in this case 24 is the lowest mandatory data rate, being the broadcast. So basically you see 3 clients and it says at RSSI 75 dBm I can decode 24 megabits per second just fine. And a client at 85 says I'm struggling to decode 24 megabits per second and this RSSI. So basically you force him to start probing again, and you reduce sticky clients. So you see that in this case you get a client that is forced to look for a next access point. Always keep in mind that roaming is a client decision. Okay, it's the client that decides to go for a roaming. So I can't say it enough, a smaller cell is better performance, not because I want to sell you more access points, but because everyone deserves good Wi-Fi. However, if you don't believe me and you still want to increase your cell, you can simply put a very strong antenna on your access point and see how is the performance. Yes, it's a real picture. So my simple rule here, a smaller cell equals better performance. All right, fill number 5. Fill number 5 is about dirty air. And with dirty air, it's like dirty underwear. You should get rid of it as soon as possible. All right? So dirty air, it's not good. Your clients will get smelly performance. So get rid of it. Let's have a look at some dirty air. In this case, you see spectrum analysis on 2.4. And in this case, you see a microwave oven. So you see a microwave oven transmitting at channel 10 and 11. And as you can see, there's quite a lot of airtime. So the darker the color, the channel utilization. So you see that there is a big impact by a microwave oven. And they tell you sometimes, and even in the books it says that older microwave ovens cause this. I can tell from experience that it's also the newer ones. They are having a big impact on the airtime. So even if you have a brand new microwave oven, this is the result. So, like I told you, I want you to become a wireless superhero. And obviously, superheroes have what they call a sidekick. So in this case, we see Batman. And what's the sidekick of Batman, Jason?
That would be Robin.
There he is. There's Robin. Absolutely. Now, we have Cow, who's got chicken. And we have...
Oh, Stephen, this is Pinky. You would think that Pinky is the sidekick, but the brain. And what's more exciting is, what are they going to do?
What are they going to do? Try and take over the world. So here I am as a wireless superhero with my sidekick. So yes, I actually brought my sidekick. So we're going to do a quick demo. So what you're looking at right now is a screenshot of my sidekick in Ekahau. And as you can see, I'm right now on channel 6 with my laptop, and we're right now streaming video, so that is why there's quite a lot of transmission here happening. So I'm going to show some more examples of wireless interference. In this case, I'm going to add a very nice Bluetooth speaker. So this Bluetooth speaker, I just turn it on. And Bluetooth is supposed to be a frequency hopping mechanism. We see my phone now connected, and I'm gonna put on a little music. So let me put on some music. I won't turn it on too loud. So this is one of my favorite bands. It's called Rancid. And the interesting thing is, right now I'm streaming. I turn off, still streaming, I just turned off the volume. But what you can see here happening is you actually see the frequency hopping happening. You see more airtime being utilized at this moment. You see it here as well. You see the little red dots. That is the frequency hopping. That's funny, huh? Here you see it. Frequency hopping. So this is just one speaker where I'm doing a little bit of audio streaming. So can you imagine, this is the impact of Bluetooth on the medium. So if you have a floor, a sales floor, where employees are using Bluetooth headsets to make calls, this is the impact that it has on a 2.4 gigahertz band. So let me turn this one off again. So, turn it off. And a next source of interference. This is a 5 gigahertz motion detector. 5 gigahertz motion detector. So right now, when I look at the 5 gigahertz spectrum, you see that it's fairly silent. So I'm plugging in the wire. So this is a motion detector like you see in your business environment. They are installed in the ceiling, in the corners. So you can see them coming up there. That is the motion detector. Now the interesting thing is, when I'm moving, see? You see that it's actually moving the signal. That is a motion detector. And look at what it does on the airtime. That's quite significant, right? If you would be using channel 153 in this Wi-Fi environment, I'm pretty sure it's now out of use. So can you imagine if you have these motion detectors throughout your corporate environment? And another interesting thing to note is that you actually see it moving. So you see it moving over time. It uses the different frequencies, and it actually moves somewhere between the right before the 153 and the 157. So you can see it happening here as well. It moves around, and especially when it detects motion. See? Okay, let me turn this off again. I'm going to put another one. I'm going to go back to 2.4. And the 2.4, any idea what this is, Jason?
I'm thinking a baby monitor, a backup
It's
camera.
a baby monitor indeed, yes, yes. So let me turn it on. I just turned it on. And right now, it starts searching for the base station.
I don't see a baby.
There's no baby on it, that's correct. So, it's searching for the base station. The base station is still off. Let me now power up the base station. So, parents, let me turn off the audio. Parents are putting this device in the baby room next to their babies. Well, if you do this, for sure, you're going to have some issues on your Wi-Fi. Look at this. This is not one channel. This is a baby monitor. Look at it. So here you see video streaming in the 2.4 gigahertz that is not made for Wi-Fi. It's quite a big impact, huh? What do you think, Jason?
I think my baby's going to be safe.
Well, I heard rumors that if you grow up with a lot of wires around you, wireless signals around you, that you become bald, but I don't believe that.
Not for a second.
Not for a second, huh? All right, I'm going to put it off. So, these are just some examples of devices that can interfere your wireless infrastructure. And this is an example, the baby monitor. If your neighbor or yourself or someone in the block is putting on one baby monitor, this is the result of the Wi-Fi. So that's why you have to keep spectrum in mind, and you have to have intelligence in your infrastructure that can handle spectrum. So you can do a spectrum analysis, which is a snapshot in time. However, you want to do sensors in your infrastructure so you will have visibility always. So these are our new 1800 sensors. You can also use the 2800 or the 3800 or the new 4800 access points, where one of the radios can be put in sensor mode. And what sensor mode does is that the radio is actually looking at the infrastructure from a client perspective. So you will see that spectrum and the performance from the client perspective 24/7. What you can do onboarding tests, you can do application connectivity, so you can actually see how applications are performing. You can analyze the network services and the packet loss, jitter, latency from an application perspective. So you can either have a dedicated sensor in the AP 1800, or you can have one of the flexible radios in the 28, 38 or 4800 series of access points, and it provides the feedback from the client. So here you see a sensor test as used with an 1850, and you can see the spectrum as seen from a client throughout your entire infrastructure. So you can actually do 24/7 monitoring. So these are really adding sensor knowledge into your infrastructure. My simple rule for fail number 5, dirty air is like dirty underwear. Get rid of it as soon as possible. Fail number 6, listen to the architect. And here I'm talking about the building architect and not the wireless architect like yourself. So one of the most common mistakes is we have to listen to the architect, and they tell us that they want to hide our access points. Why? Well, our access points are ugly. And what do we do with things that are ugly? Well, do things that are, in my opinion, definitely ugly. You can tune them, pimp them, but they still look ugly, right? Even if you go all the way, it becomes funny, but they are still ugly. So, what do you do with things that are ugly? You want to hide them. So they put the access points above the ceiling, behind the wall. They put the access points away. But with Wi-Fi, you have to put your access points where the clients are. And it's really important for the performance of an access point that you put the APs where the clients are. The reason for that, this is the official one. I made a simple one. We have a transmitter and a receiver. And in this case, we put an object in between, and let's say that's a wall, or that's a drywall, or it's a ceiling. You put an object in between the transmitter and the receiver, and basically, if you're going to have a second object, you have an access point above the ceiling, and then you have a client on the other side of the wall. There's two objects that are reducing the signal by half, and then another time by half. Then the signal that is received by the receiver is a lot weaker. So how I like it is that if you want to hide the access points, that you use material for it where you can properly install it on the ceiling, and it actually looks nice. I mean, an architect will not have a problem with a device installed like this. The RF mathematics, I don't have to explain it for this audience, but 3 dB is 3 dB gain is doubling the signal, and the 3 dB loss is half of the signal. So in the case of an access point, the max is 20 dB, so a 3 dB loss would actually mean 17 dB, which equals 50 milliwatts. But in the case of our wireless infrastructure, 70% of the clients are what kind of devices? Exactly, it's those smartphones. And those devices are actually transmitting on a maximum of 14 dBm, which equals 25 milliwatts. And we always want our infrastructure to be on the same level. So you want your infrastructure to be on 14 dBm. So the access point and the client can actually hear each other on the same level. So in this case, if we have a transmitter and a receiver, if we have the transmitter being the access point and the receiver is the smartphone, then if you flip the two around, the signal actually becomes a lot weaker because the client is only on 14 dBm. And if you then put a wall in between, then actually the signal becomes half of that. So, access points are ugly. Well, dear architect, what about these? Dear architect, why are you not hiding these devices? Why don't you put them behind the wall or behind the ceiling? If you ask that to the architect, what do they say? They tell you, then they don't work. And the next time when the architect is telling you, we're going to put the access points above the ceiling or behind the wall, ask them, what about those? Why don't you hide them? They will tell you, then they don't work. And then your reply is going to be, aha, the same goes for Wi-Fi. So, there's a thing called the Peephole Ap. What can you imagine by the Peephole Ap? There you go, you've probably seen it. And let's be honest, it's ugly, but it's a lot better than putting the APs above the ceiling. This is how it looks in a hotel room. Yes. And even though it's really ugly, it's still better than putting the APs out of sight all the way behind the wall. But this is how I want to see it. If you want to hide the access points, this is how to do it. And if you want to completely hide them, this is a mechanism where you can simply put them behind a plastic, and you can even paint the plastic. So you can paint the plastic in the same color as the rest of the walls or the ceiling. Keep in mind it should be a non-metal painting, but in this way you can properly hide them. For outdoor, this is a way to put outdoor access points without you seeing the outdoor access points. So it looks quite nice to install outdoor Wi-Fi like that. So my simple rule, can you read the logo? You're probably good to go. Okay? So if you see an access point and you can see the access point but you can't read the logo, then probably the access point is too high. Okay? 10 feet max, or 14 feet max, or 4 meters. And you got to keep that in mind. If you're going to go above that, you will need to work with special antennas. If the access point is higher than that 14 feet, you probably cannot read the logo. And the same goes if you are in an office room and you can't see the access point, but it's there, then probably the access points are above the ceiling. So if you can't read the logo, if you can read the logo, you're probably good to go. Fail number 7, the installer is always right. So, you as a wireless specialist, you design for capacity, not for coverage. You design primarily for 5 GHz, proper channel overlap, dual radios and high density, suggested to work with 40 and 20 MHz wide channels. You have clean air in the sensitive areas, and then the installer comes and takes your plan and installs the access points where it's most convenient for them. Why? Because the wire was there. Because it was easier for them to install it there. Because, well, there is no because in this case. It looks even ugly. So the simple rule is stick to the plan. You are a wireless specialist and you created a plan of where the access point should be placed. So it's really important to stick to the plan. So, in closure, a lot of things that has changed since the beginning of networking. Think about the devices, the applications, the use cases, the locations, and the way of working. A lot has changed since the early 90s of networking. It has a big impact on the infrastructure, the priorities, the budgets, who's paying for it, the security. I mean, the fact that we can normally, we think it's normal to use your wireless device from anywhere, opening corporate data when you are in a public hotspot or in a coffee bar. That has a big impact on the security, and our way of thinking about working really changed a lot since the beginning. And to keep it in mind that this is 1991, and in 1991 you would see everything that you see in this Radio Shack advertisement for $5,500 US. You would buy a machine, you would buy a stereo radio, an alarm clock, headsets, a calculator, and everything that you see in this picture you would buy as separate devices. Now in 1991, to put it in perspective, a lot has changed since then. I mean, we were looking at Novell NetWare, we were running 3.1 on our 386 machine. Vampire taps were actually a thing. Token ring networks were still the most efficient way. Token ring was more efficient than Ethernet. We were watching Robin Hood and the Prince of Thieves and listening to Bryan Adams. Everything I do it for you. We were watching The Silence of the Lambs. We were playing Sonic and Mario. Terminator 2 was in the cinema, and everything that you've seen is now available in one device, and that has a big impact on our infrastructure. Big impact. So there's a lot you can do wrong in Wi-Fi, but it's not always the Wi-Fi to blame. I mean, try to change a patch in this environment. Or you as a wireless specialist did a great installation. You did everything by the books and you implemented the infrastructure and it's perfect. And then they install the wireless LAN controller and they close the door and it snaps the fiber optic cable. Down goes the Wi-Fi. It's not always the Wi-Fi to blame. There's a lot you can do right and a little bit of understanding and reading about the technology. So another thing that I wanted to give to the wireless community is build your house. And build your house is about setting the foundation with AP placement and density. And for this, of course, you would do a site survey. You would tune the transmission power, so maximum of 14 dBm or 25 milliwatts, and proper channelization. And my recommendation would be to work on 20 megahertz wide channels in a very high density environment and 40 megahertz wide channels in a normal business environment. You would tune the data rates, and then you could do fine tuning on top of that and enable 802.11k V and R on top of those infrastructure. And with that, you create a solid house. And remember that a home is where the Wi-Fi connects automatically, right? So, in closure, it's really important to stick to the plan. But be careful when you emphasize to the installer that it needs to be installed in that exact location. Before you know it, they will drill a hole in the wall because you said that you want the Wi-Fi to be installed in that exact location. So, reach out to me for the famous 14. You can find me on Twitter and I will send the file to you for free and you can use it and please share the knowledge on Wi-Fi. There's a lot of knowledge on Wi-Fi. We have independent blogs, there's the vendor blogs, and you already know the Cisco full bars. Thanks for having me, Jason. With that, I want to thank you and see you next time.
Stefan, thanks again for coming back for a special edition. Looking forward to seeing you at Cisco Live in Orlando, right?
I'm going to be there.
Excellent. What's the name of your class in case people want to sign up?
It's called 7 New Ways to Fail. I'm going to do this live session. I will do some more interference in the demo there. Yes.
That's great. Hope to see you there.
Thank you. See you next time.
This has been a presentation of Cisco's Wireless Tuesday. Be sure to continue the conversation at ciscofullbars.com, and at the top, click on the CFB Spark community. There, you can connect with scores of like-minded wireless LAN professionals. Be sure to subscribe to the Wireless Tuesday podcast using your favorite podcast player, and stay up to date by subscribing to the Wireless Tuesday newsletter at wirelesstuesday.fm. We will see you next month for an exciting episode of Wireless Tuesday.